All right, hey guys. This video is about rationalizing the denominator when you have complex or imaginary numbers. Um, so problems kind of like this. Actually, I'm going to start off with a simpler one here. Let's do something like this. So the deal is you cannot have an I in the denominator. You can't do it. So if you have a problem like this, we have to rationalize or change the denominator somehow so it doesn't have an I in it. So in a problem like this, you can multiply the top and the bottom by I. Now this is equal to 1. So I'm not actually changing the value. Multiply something by 1 doesn't change the value of the expression, just the way it looks. So I divided by I, that's 1. Let's see, 5 times I, that's just 5I. 6I times I would be 6I squared. But what's I squared? So my final answer is this. I'm good because I got rid of the I off the denominator. I'm done. Problem is, ones like this, a little more complicated. You can't just multiply it by I. That wouldn't help. It wouldn't get rid of all the i's from the denominator. So what you have to do, multiply the top and the bottom by the conjugate, the complex conjugate of the denominator. It's pretty simple. Just rewrite it, but change the middle sign here. If it was negative, make it positive. If it was positive, make it negative. Yeah. And on the top as well. So that's it. So from here, it's just foiling and simplifying. Just normal stuff we've been doing all the time. So let's see, on the top, that gives us negative 8 plus 5i, and on the denominator, let's see, negative 8 times negative 8, 4, negative 8, so I'm foiling, right? This is you got a foil down here. That would give us negative 40i, and then this would give us a positive 40i. That's why we use the complex conjugate, so that these would cancel out. And then that last one, negative 25i squared, you can cancel these out. Yeah, you have an I squared, but I squared is negative 1. So this is really plus 25. So your final answer then is negative 8 plus 5i over 64 plus 25. This would be 89. Sorry. Yeah, and then we just, if anything simplifies, we would. But there's nothing that we can do, so just leave it like that. And that's it. So let's try another one of those. Okay. It's a little more, I mean, same process, just a little more complicated on this one, because the numerator is a little more complicated. So let's see, first question is, what are we going to multiply the top and the bottom by? So you have to decide what's the complex conjugate of the denominator. So it would be negative 6 minus 6i, top and the bottom of that. Again, notice, look, anything divided by itself is 1. I'm not changing what this is worth. I'm just changing how it's written. Okay, so now I have to foil on the top and foil on the bottom. Oof. So let's just see here. That would be 60 plus 60i plus 30i plus 30i squared. Okay, we'll simplify that in a second. On the bottom, should have some things cancel out, so this would be 36. Let's see, that would be plus 36i squared minus 36i. Oh, sorry, not I squared, just I. And then the last one would be minus 36i squared. Oof, okay. So those cancel, that's what I wanted. And that I squared, that's technically negative 1, so that becomes plus 36. And so I have 36 plus 36 in the denominator. So the denominator will just be 72. Okay. And then let's look at the top. You got I squared, that's negative 1. So this is really saying minus 30. Okay. So that's really just minus 30 there. 60 minus 30, 30. And then 60i plus 30i plus 90i. Okay, now see here, we have some things to cancel. I just looking at this, I can tell that, actually no. I wonder if threes will cancel. I wonder if there's a 3 in common here. I know at least there's a 2. Let's see. Okay. So let's just look and see if we just do the 2's. So that will give us, divide everything by 2, you get 15 plus 45. I over 36. And yep, is a 3 and everything there. Make sure I'm messing this up. So let's see, 15 divided by 3, that gives us 5. Plus 45 divided by 3, that would be 15, right? On the bottom, that would be 30, that was 12. Yeah, cool. All right, and then so that's just our final answer. Ooh, all right, so yeah, even once you get here, you still have to simplify it, as we've always done. That's not new at all. None of this was new. Only the really new thing here was just this complex conjugate, and then the whole I squared being -1 thing.